Okay, so today we want to talk about what happens on what we call the ambiguous case. And it only occurs if you know the following. If you know a side, and an angle, there's a possibility of one of three things happening. Okay, I won't draw these to scale because we did that in class, but if you were to draw the scale and you had angle A, 40 degrees. Let this be side B. Let this be side B and let it be 7. And then if A is 6, you don't know how long this one is, but it could be as long as you want. But if you try and fit in the 6, let's say you try to fit in the 6 with your ruler, okay, you could get a triangle that looks like this, okay? If this is angle A, then little a, side A is directly opposite. Let's make this be 6, okay? This is the case where you have only one triangle possible to draw, okay? And that's easy. We can solve that using the law of sines. We know this is angle B and angle C, and we'll use the law of sines to solve that. I'm going to leave that alone because we've talked about that, okay? Let's go on to question 2. Again, it's called the ambiguous case, all right? Question 2, if you were to draw this, it would look something like this. Again, we did this in class. You've got a 50-degree angle. So put a 50-degree angle here and let B equal 8. Again, I want to put B. I think it's easiest to draw B on this side. I really do. And then what happens, you don't know how long this is. What will happen is if you draw in the 3, it's too short. It doesn't fit. So there's no triangle. None at all. Again, no triangle. Okay? So again, if you know just the side, and the angle, you have the possibility of not having a triangle at all. It won't work. And that's why we draw these to scale so we can see that, okay? And then the third case, which I'm going to do and actually show you to scale, is where there are two possible triangles. And I'm going to show you that in a second. Okay, it could look something like this, where you've got your angle, your 30-degree angle, and your other side could come down here like this at 5. But somebody else might say, wait a minute, can't you draw the 5 here? And you wind up with two totally separate triangles. So there's the possibility of two possible triangles. Okay, now let's go back through this. Okay, if you have the ambiguous case, how do we know it's ambiguous? If you know a side, and an angle. That's all you know. And you were to draw it, you could get the possibility of one complete triangle. It's easy to solve. You could get a possibility of no triangle. This does not exist because this isn't long enough to reach this. And you wouldn't know that if you solved it. And then the possibility of the third case, which is two possibilities. Okay, so you could have two triangles that are possible, one triangle that is possible, or none at all. Now, let's do one of these, okay? So I have an example that actually shows it pretty well. I'm going to draw this to scale, okay? This is worth a lot of points on this next test, so let's see if we can do this, okay? So let's start with, first of all, I want to draw angle A to scale. So I want to draw an angle. So I'm going to put a point for point A, okay? Just put a point, call it A, because that's where I'm going to make my angle A. I'm going to go ahead and extend and make an angle, so I need a line, terminal side of my angle, so I can put my protractor on this line. I use my protractor and I zero it out. See my zero there? Protractor zeroed out. I need 35 degrees. Okay, 10, 20, 35 right there. Okay, now I want side B to be this side. I want it to be 8 centimeters. So I'm going to take my ruler and draw it out 8. Okay, let's let this be side B, which is 8 centimeters. Okay, just use my ruler to measure it. I drew it out exactly 8. Okay, this is 35 degrees, which is angle A. Okay, so far I've drawn my angle A, 35. I've made my side B, which is 8 centimeters. Now, little a, side A, has to be opposite of angle A. This is angle A. Little b is opposite of that. So what I'm going to do is try and put the 5 in. So I'm going to draw the 5, and I've got to make it fit, because that's, if I draw it straight down, that's not 5. That's silly. I want it to be 5. So I move my ruler to make it fit. and it fits right about there. Okay, that is side A, which is 5. Okay, and we will solve this. Okay, so we've got side B, which makes this be angle B. I need triangle ABC, AB, so this will have to be angle C, which will make this side C. Okay, now I'm going to erase my extra because I don't need it. All right, erase my extra. So far so good. Okay, here we go. Now, what I'm going to do with this is I'm going to go ahead and take a look at trying to solve this triangle. Okay, now there will be 2 triangles, but let's solve this one first. Okay, so I'm looking for my opposites. Opposite, opposite. I have the side B, which is 8, so I should be able to find angle B first. So let's find angle B. So I'm going to go, okay, I can do that. Okay, sine, opposite, opposite. I'm going to go sine of B. Sine of an angle over its opposite side equals sine of 35 over its opposite side, which is 5. Okay, I'm going to cross multiply. I'm going to bring up the 8 and bring it here. I'm going to need a calculator, so hold on. I'll give you a chance to pitch up. Okay. So I'm going to go ahead and go sine of B equals 8 times the sine of 35 over 5. 8 sine 35 divided by 5. And I get a decimal. And that makes sense to me, the decimal, because I'm going to have to find the angle. So I need to do the sine inverse of that. So we're going to go sine inverse of that number, of that answer, of that point. Because I need to find an angle, so I need to use the inverse button. So I wind up with about 66.6 degrees. Wow, that's a weird number. So angle B is about 66.6 degrees. All right, so let me put that in there. My 66.6 degrees. Okay, so far so good. Now, if I want to find angle C, what I'm going to do with angle C is then I know in a triangle there's 180 degrees, so I'm going to go, okay, angle C, 180 degrees. I'm going to go 180 minus my 35 plus my 66.6. And I use my calculator, 180 minus parentheses, 35 plus 66.6, and I get an answer of angle C is about 78.4 degrees. So I'll put that in there too, 78.4 degrees. Okay, I've got all 3 angles from 180. And now what I'd like to do is find little c. Okay, I'm going to do my opposites again. I'm going to do my opposites, so I've got little c and I've got angle c. So I can set up my opposites. So I'm going to take and do my opposites. So I'm going to go little c, side c, over the sine of its opposite angle. Okay, sine of 78.4 equals, same thing, I'll use the side, the 5 over the sine of its angle. So I'll go 5 over the sine of my opposite angle, which is 35. Okay, and I'm going to solve. Okay, I'm going to multiply up the sine of 78.4 to get c by itself. So I'm going to rewrite c is equal to 5 times the sine of 78.4 divided by my sine of 35, and I'll use my calculator to do it. Okay, so I'll go, okay, 5 times the sine 78.4 divided by sine of 35, and I get an answer of about 8.5. So side C is about 8.5 centimeters. Okay, so let's go back through what I did. Okay, I drew my triangle to scale. I set up my opposites. I was able to solve for angle B. I then, from 180 degrees, got the third angle, angle C. And then finally, I found side C by setting up the opposites, side or the side of its opposite angle, side of the opposite angle, and found little c. Now, however, here's what makes this problem a little bit weird. There are 2 possible triangles. So where's the second triangle? Well, let's go back and redraw this. Okay, I have my angle A, which is 35 degrees. Okay, and I have my B, which is 8. Now watch. Watch this. This side here this side here, we don't know the length of it. It could be anything. But I know this side's got to be 5. Well, there's no reason we couldn't have drawn the 5 here. Follows the rules. There's that opposite side, which is 5. So I wind up getting a totally different triangle. Right here is 5. So the triangle I could solve for also, so there's 2 possible triangles. They both follow the same exact directions. The second triangle is right here in orange. Let's take a look at it. So it follows the rules. I have angle A is 35. Yeah, that follows the rules. Side B is 8. Yeah, that follows the rule. And little a, which is opposite, is 5. Yeah, that follows the rules too. So I have a second triangle. So on the test, I'm going to ask you to draw this in both triangles, and I'm going to ask you to solve. Well, here's the key. Solving it's not that bad. So this is the other triangle. Let's solve that. So first of all, 5 and 5. So we're going to go back to the fact that if this is this triangle in here, that's 5 and that's 5, is an isosceles triangle. Here's the trick. These 2 angles are equal. These 2 angles are equal. This is not the triangle I want to solve, but these 2 angles are equal because base angles of an isosceles triangle. 5 and 5, 66.6. Okay? Now, angle B is not here anymore because we've got a different angle. We've got a different triangle. Angle B is really, angle B, because we want this triangle, is really here. This is angle B. Well, to get angle B, I know that in a straight line makes 180 degrees. So to get this angle B, I'm going to go, okay, that's easy. 180 degrees minus my 66.6 will equal angle B. All right? So I'm just going to put 180 minus my 66.6, and I get an answer of angle B to equal 113.4 degrees. Okay? Good. Now, again, I'm looking at the orange triangle because the orange triangle is my second triangle. And angle C now is not all of this. It's not 78.4 anymore. It's a lot less, isn't it? Okay, so I need angle C, same thing from 180 degrees. 1, 2, 3 angles. All 3 angles add up to 180 degrees. So angle C would equal then my 180 minus the sum of these 2. Sum of my 35 plus my 113.4 degrees. Okay, so I'm going to go ahead and subtract those. 180 minus my 35 plus my 113.4, and I get an answer of about 31.6. Yeah, it's about a 31.6 degrees. Okay, so I'll put that in there. It's a 31.6 degrees. Okay. All right, much smaller. We're doing again, we're working on the orange triangle. Okay, now, I haven't found all of the orange triangle yet because I need to find this side. Okay, that's little c, which is certainly shorter than the original. Okay, I want that side. But I'm going to set up the same way with opposites. Okay, I'm going to solve the same way we did down here, but with different numbers. Okay, side, little c, side c, over the sine of its opposite side will equal a side, which is the 5, over the sine of its opposite angle. Okay, and I'm just going to solve for c by multiplying that up. So little c is equal to 5 times the sine of 31.6 divided by the sine of 35. Use my calc 5, sine of 31.6 divided by sine of 35, and I get an answer of about 4.6, approximately 4.6 centimeters. Okay, so that is the ambiguous case. And you'll have one like this on your test where you're going to have to draw it correctly, and you're going to have to find and solve the original bigger triangle, finding angle B, finding angle C, and finding side C. And then you're going to have to draw the other triangle inside, and you're going to have to find its angle B. You're going to have to find its angle C and its side C. All right. If you have any questions, come see me, but I'm going to post this.